So everybody does have that practice test, right? I think I brought copies, so hopefully you do. So that's one thing you can ask questions from. You can ask questions from the quiz, obviously. You can start making corrections. If you don't have any questions, just get corrections done and out the way. If you guys really don't have many questions, this could be a very, 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 very short class. Because it's all built around whatever questions you guys have. Yes?
Do we need to have all of our quiz corrections complete by Wednesday, or can we have until Monday?
If you want as many points back as you could get, Wednesday. Yeah. And then, you know, the later it is after that, the fewer points you could get back. Yeah. Kind of makes sense. Does it make sense why I do that? Does anything I do make sense? I don't know. It's like, nice to be, check that sometimes. Because that helps you get ready for the test, right? Now, it will help you get ready for the final, but kind of want it looked at before the test. Yeah.
So the corrections for the test, does it include the curve, or
How do you mean?
like the points?
Yeah.
So I got 91 right, and then with the curve 93, and then I did the corrections, I got 96, so.
So did you get all the corrections right?
Yeah, why was it?
No.
No?
No. Yeah. Yeah, sure, sure.
Just wanted to make sure, like.
No, yeah, I do. So you could have gotten up to 98.
Okay,
Yeah,
so it's
yeah.
5 points. plus
5
the
points,
curve.
for above 80, yeah.
Okay.
So if there's any corrections you don't do or any you don't get quite right, you're not gonna get the full
Oh.
points, yeah. Okay. Any questions, guys? Y'all look very upset, I'm sorry, that spring break ended. Yes?
Do 6B.
6B. Oh, yeah, okay. So for 6B, what kind of series is this fundamentally? What kind of series is that? Alternate, beautiful, right? And this problem, I don't say anything about, now on the actual test, I will make a distinction between show if it's conditionally convergent and absolutely convergent. Here I sort of left that open, so you should check for both. So can anyone tell really quickly if this is going to be absolutely convergent? If I check for absolute convergence, that just means, what am I looking at?
The absolute value.
Yeah, absolute value in this. Which is gonna roughly look like what? I think you just said it. 1 over n. Yeah. Yes.
I don't know if it matters, but it's -1 to the power of n plus 1.
Oh, thank you. Okay. So that looks like it's not gonna absolutely converge. So how do you check conditional convergence? That would, you just leave it in, right? And so what do you apply then in the case of this kind of series? And you guys just told me what kind of series it is, right? Alternating series. So there's an alternating series test. There's really only 2 things. There's 3 sort of. I mean, there's one condition where all the elements have to be positive. And that one normally they're not going to make it negative somewhere. But are all the elements of this thing positive? How do you think you can show that real quick?
Take either the integral or the derivative?
No.
Or no, the limit.
That would be to show if it's decreasing, right? Now, you do have to show that the limit is 0. So what's the limit, of course, of the AN piece? That you don't have to do any work, right? We can use the old idea about horizontal asymptotes. Man, you guys look beat up. You guys alright? I'm sorry. Shit. I'm really sorry. I feel bad sometimes after a break. I'll say, "Was it good?" And somebody will go, "No." Oh shit, I'm sorry. Didn't mean to bring it back. Alright, so it has been a little while. I agree. Thank God you don't have a test tonight, right? That would be extreme, like I said. That would be extreme. Tonight's the night to just review everything. You can just say, I don't remember what the hell P-series is. Yeah, whatever. It's wide open. You can ask me any damn question about anything from chapter 11 we've done. 11.1 through 11.5. Right? Yeah.
That one that we're working on today, the finding if it converges or diverges of 5 over n to 1 plus 1 over n. You know how
Okay,
like
so-
the P-series and
Yeah, we'll look at that one next. Sorry.
to 2. And
Two. Okay. So we'll look at that one next. Okay. I like it. Real quick. So alternating series test. They have to be positive elements when you take the negative 1 away. The limit has to be 0. And what's the third thing? Kind of gave it away earlier.
It has to be increasing? Or
Increasing with stuff. Yeah, decreasing.
increasing?
Because always keep in mind, the most obvious visual of a series that converges would look something like that. So it can't be 1 over n, it has to be 1 over n squared, but it would basically have this shape. So that should tell you a lot of things. It should be decreasing, right? It should be approaching 0, yes? Okay, so the third thing is it's got to be decreasing. And there's 2 ways to show decreasing. So what is this limit? Good old pre-calc, good old horizontal asymptotes. The bottom degree is more than the top, so the limit is
0.
0, right? Is everybody cool with that? No work to show that. That's just a root fact now. We know that from pre-calc. Or if you don't, we'll pretend like we do. Okay. So it's all about comparing degrees, top and bottom. So check. Are all the elements positive in this? So the only thing that we don't know, so when n is 1, what's this?
Negative 1?
Negative 1, I love it. But when n is 2, what's this?
Threes?
Yeah, it'll be 4 plus 10, right? Wouldn't it be 4 plus 10 minus 7, 7. Right? So the funny thing about almost every condition, it just has to start and be true forever after some value of n. We talked about that, like for an interval test, it's supposed to be decreasing, but it could increase for a while and then decrease forever, as long as it decreases forever after some point. And I really want that to make nothing but sense. The first finite amount of time that it's not decreasing, that would be a finite sum. So the only way it could be infinite is if the rest of it goes to infinity, and the rest of it I could use the integral test on because it's decreasing after that, right? So that's why it only has to start doing these requirements at some point forever after. Because the first part of it doesn't mean shit, it's just a finite number. I don't care how big that finite number is, it's nothing compared to infinity. Okay, maybe. So, this is not true for n equals 1. How could I show very quickly, and again, I love you guys are out there going, holy shit, we can't even show the damn thing's positive. Well, what's the bottom? The top is n. That's positive, because n goes from 1 to infinity. It's positive by definition. What's the bottom look like if I graph it? Gravity, right? And if I knew, so at 2 it's positive, correct? And at 1 it's negative, yes? So if I knew where the vertex was, if the vertex is less than 2, that means it's going to be increasing forever. Isn't that true? In fact, I shouldn't have to do any real work here because this parabola is going to look like, it's going to, I don't even want to draw that, it's going to look like this, yes? Mm-hmm. So wherever the thing hits, it's going to be increasing forever. It's going to be positive forever after that, right? Okay, maybe. So again, you have to capture this idea. So this is certainly positive. You can either find the vertex and show, but this is definitely positive, check. It's definitely limit is 0, check. And now we just have to show it's decreasing. and then the alternating series test would be fulfilled, right? So what's the quickest way? There's two ways to show something's decreasing. I'm getting way too many people. So one way to show it's decreasing is to show the next term is less than the term before it. That would so desperately suck here. I really want you to understand. What's the next term look like? Here's the nth term. What's the n plus 1 term look like? That's the nth term. What's the n plus 1 term look like? N plus 1 over n plus 1 squared plus 5 times n plus 1 minus 7. And you have to show that that's less than n over n squared plus 5n minus 7. Not the most straightforward thing in the world to do, right? So I'd much rather just do a derivative. Now derivatives, especially quotient rule, so you guys have trouble with the algebra. You normally get the first step correct, and then the algebra just kicks your ass. Right? I'm not saying that to make you feel bad about yourself. It's just easy. When you get to a certain level, you're sort of like not as focused on the algebra, right? Okay, I like it. I remember I had a class, and the teacher would always go, and the rest of this is algebra, and everybody would be like, do it! Do it! Okay. So can you guys, real quick, let's do this real quick. You guys do this. Take this guy's derivative. So let's look at this associated function. Take the derivative of this function.
So when we're checking if it's decreasing, we don't have to do it on the original equation?
You do. Everything you do here is related to the AN piece. So this piece has to be positive. This piece has to be limit 0, and this piece has to be decreasing. Because inherently, it's like not going to decrease if you include the -1 piece. Yeah. This one's kind enough. I think the first step is nice, right? So zero at the top. What? Minus the top times 0 at the bottom. Right? All over the bottom squared. People get freaked out about this. My God, do not waste time squaring that damn thing out. Right? What's the only thing I care about right now about this? Do I need to know any numbers? Do I need to know any? Do I need to simplify it? Do I need to simplify it enough so I can see what?
It decreased.
If that is always what? What would it mean for it to be decreasing? The derivative would be? Negative. I just got to see if this thing is negative. What's the bottom always? Positive. Right? It could be 0, but I'm using whole numbers. So there's no way that could be 0 on the bottom. Right? So now all I care about then is what's the top? Whatever the top is the answer. Is it decreasing or increasing? Right? If it's negative or positive. So what do I get here?
Negative x squared.
Good. X squared minus 2x squared, negative x squared, plus 5x minus 5x, yes?
Yeah,
Minus 7. So what is the top always?
negative.
Freaking negative. That is less than 0, therefore decreasing, check. So people shy away from derivatives. You have a little trouble with the algebra, then you have trouble interpreting what the hell you got. And again, I'm not coming down on you, because a lot of times we don't focus on some of the algebra, we kind of forget. And then some of the interpretation, we don't really focus on that a lot. We kind of put that on your shoulders a little much. I'll do the same thing, but I'm trying to show you. You can see very easily. Is it very cool? That is always negative. For especially for the values we're looking at, but for anything that's damn negative, right? I like it. Okay. So check, check, check. So therefore what?
Converge.
What kind?
What is it called? Conditional.
Conditionally convergent. You can call it con-con. I like it. So absolute convergence makes almost too much sense. It's when you take an epsilon. Conditional doesn't make as much sense, but it's based on the condition that you leave the negative stuff in. Right, that's why it's called conditionally convergent. Okay. So let me ask you kind of a tangential question. Tell me what you can about this. This series here. What can you tell me about that one? That's infinity, by the way. It's halfway between an 8 and an infinity.
It would absolutely converge.
Say again?
It would absolutely converge.
Okay.
Is that correct?
And what do you think? If something absolutely converges, do you see how technically it has to conditionally converge then?
Yeah.
If something absolutely converges and then you allow every other element to be negative, it definitely does.
Oh, yeah.
But we wouldn't say, if we just say conditionally, that means it only converges if we leave the negative in. So what would the answer to this be? Absolutely converge. In fact, if I ask you, is this absolutely or conditionally, the first thing you check is absolute, because if it is absolute, you're done. Do you understand? If it's absolute, don't do alternating series test. Why the shit would you do that? Does that make sense? Absolute's much stronger than conditional. In fact, the word is stronger than, right? Absolute. Conditional. So if you can show it's absolute, you're done. Because it automatically conditionally converges if it's absolutely convergent.
And just saying that since P is greater than 1, they can.
Oh, yeah. So here you'd say absolute convergence because blah, blah, blah. P is greater than equal to 3. In fact, get used to saying P equals something which is greater than 1. And so therefore, P series converge. Yeah, I love it. I just want to make that clear. When I ask you to check the different kinds of convergence, do absolute first. Because if it works, you're done. Kicks a lot of ass. Okay. And that's why in the first one, this guy, we did absolute convergence and it looked like it was going to be 1 over n, so that was going to be a no-go. Then we had to do alternating series test. Okay. Anything else you've tried from homework? It could be from the quiz. It could be from the practice test. Does anybody else not get their quiz back? Yeah.
Katie?
And just so you know, the average on the quiz was 78. So you can make corrections just like any other quiz. They are due this Wednesday. Yeah.
And then I did have a question.
Oh yeah, we wanted to do that other one, right?
Yeah.
And I erased
5,
it.
Yeah, 5 over n to the power 1 plus 1 over n.
Yeah, this one's cool. Okay.
Because I'll let you do it, but it didn't come out to be what we talked about, so I got a little confused when we did it.
It did what?
It was divergent.
This is divergent?
Yeah, and when we did it, we showed or how you showed me, it looked like it was convergent.
Yeah.
I'm
Yeah.
confused.
No, this is definitely convergent. So what told you it was divergent?
The computer.
Oh, the computer is
On the
having a
homework.
moment.
So,
Let me see, is it in, what section was it in?
11.4.
Okay, so they might have a similar question here. Well, let's see, let's do this. Let's talk about it, and then I'll see if I can find similar. I don't see one right off the bat. Shoot. No. Okay. Oh, well, no, that's not quite it. Shoot. Well, let's talk about this one.
N equals 2.
Okay, thank you. So tell me this. Do you guys see? All right. What type of series do you hope to God I give you?
P.
P series. Oh my God, right? P series. Yeah, Jeff, all the freaking day. What's another really cool series?
Geometry.
Geometric. Holy shit, right? If it's geometric, you better be all over the damn thing. You with me? Don't mess up on those. Get those. Could this be geometric?
Could, right?
Maybe,
No.
no?
Geometric, the base has to be, can the base be variable? No, base has to be number, numeric. Here the base is n, and the power is also n. But, do you see how this, I really want this to make sense. Here's what a p-series looks like, yes? One possibility for a p-series. Let me put a 5 up here, that's still a p-series, right?
Mhm.
So what's p in my expression?
1 plus 1 over n,
What's got to be true about this for it to converge?
greater than 1.
Greater than 1. So what's got to be true about this
It's
for it to
Greater than
converge?
1.
1 plus 1 over n has to be
Greater than 1.
greater than 1. Now, I will admit, this is sort of my shortcut approach. But, again, if I do this, does this converge or diverge? You already know the answer, right?
Yeah.
Does that converge or diverge?
Converge.
Converges. What about now?
Yeah.
I can do it all freaking day. How far can it go? And it would still converge. Forever. Yes?
Mhm.
As long as that power does not equal 1, as long as it's greater than 1, this will converge. So when is this not true? Well, if you do this, right? When is that not true? Is it,
That's zero.
well, 0 is crazy true, right? Because 1 over 0 would be approaching infinity. That's definitely bigger than 0. Go the other way. What about a billion? Is this still true for a billion?
Mhm.
Yeah, all this is saying is 1 over n has to be positive. Do you see that? Isn't that what that says? Is 1 over n ever not positive? So this is really a question of limits. When does 1 over n equal 0? Does it ever equal 0? Good. But what is the limit as n goes to infinity of 1 over n?
0.
Good. And so when you first learn limits, what you just said to me made no freaking sense. Do you guys remember? The limit was 0, but it never equals 0. And when you first learn limits, you're like, what the shit are we doing? No? Do you remember those days?
Yeah.
Okay. But does it make sense now? The limit being a number does not mean it ever gets there. It just means it gets as close to that as you want. Right? In fact, what does this look like? What does 1 over n look like? Like that. Asymptotic. So in order for this to converge, this power has to be bigger than 1, and this power is bigger than 1 always. So the fact that they said diverge,
I'll send it to you too, because we were all
Yeah.
confused about it too, because I just started redoing it.
okay.
So,
And again, that was programmed by humans. Humans make mistakes. And that's, again, why I don't like online homework. Right? If anybody makes a mistake, I want it to be me. I'll have to see if it's in, I don't think it's, that's weird. Oh well. Okay. So that one's a really neat one. And it's a good example of, oh, there it is. Okay, now I'm curious. Now I have to look up this one in the solution manual and see if they get that one right. Okay. This one's really exceptionally weird because I don't know how many of you would have thought to think of this as a p-series without me kind of pushing you in that direction. And if you didn't, I wouldn't really blame you because it's not a constant, and that's what a p-series is. But for any value of n, isn't this looking like a p-series? Okay, maybe. In fact, I mean, if you look at this series, and to the end, is that a p-series technically? No. Is that like a p-series? Yes. Right? And if n starts at 1, no, it will still work because I can just chop. What's the first element? If n equals 1, what do I get? If n is 1, I get 3.
It's smaller.
Right?
It's cheap.
A little bit, but not really. Right? But again, the point is it a power of 1 forever? No. Are the powers that it is bigger than 1 forever? Yes. Is the powers that this uses, are they bigger than 1 forever? Yes. So I disagree very much with whatever programmer did that. So I got to remember to check it. if you're able to, if you could send me an email saying,
I might do a little ask teacher thing.
okay, good. I just have to log in, because as much as I try to tell it to send me queries to my email, it won't. So I just have to log in, and then I see like 12 unanswered, I'm like, shit. All right. By the way, there is something in the book that you'll see a lot that I don't think we've talked about directly. Is everybody cool with this here, or, you know, semi-cool with it? Okay. Is this idea, remind me, did we talk about this idea?
Factorial?
Yes. Or did Patrick talk about it?
I don't think so, actually.
All right, so that kind of got lost when I was in and out of COVID. But here's the idea of a factorial. This happens a lot in probability, and also it happens a lot in calculus. So we have these factorials, and what a factorial is, for example, 3 factorial is 3 times 2 times 1, which is holy. And then 5 factorial would be 5 times 4 times 3 times 2 times 1, right? 120. And of course, there is a 4 factorial. I didn't skip it because it didn't exist, but you know, there's the idea. So what is n factorial then? Do exactly what I just did. N times so if n is 1, this tells you to stop here. You stop when you get to 1. You stop here, actually, right? So n factorial, 1 factorial is 1. What do you think 0 factorial is? So watch this, it's kind of cool. Are you guys a little bit intrigued? Does anyone know what 0 factorial is? If you do, don't say anything. So let's figure it out. Watch, this is so cool. Okay. And I don't know if you guys get annoyed when I'm all excited or what, and I don't give a shit. I'm excited, who cares? What's 3 factorial again? It's 3 times 2 times 1. How do you get from 3 factorial to 2 factorial? Don't you divide by 3? Yes? To get from 7 to 6 factorial, I lose the 7, right? So I'm going to divide by, so I would take 3 factorial divided by 3. So how do I get 1 factorial? I would take 2 factorial divided by 2. So how do I get 0 factorial? I would take 1 factorial divided by, do it, 1. So 0 factorial is 1. Not by definition, but because. Right? And we're not going to get into this, but just to kind of lay the groundwork, and you can look it up if you want to, but if you get far enough in mathematics, you'll actually learn what the hell 1/2 factorial is. Does anyone agree that is exceptionally weird? Even weirder than 0 factorial? We're not going to get into it because obviously it's a little more summer. Yes?
Well, since we are getting into it a little bit,
Not
there
really.
was a problem where it was 22n factorial over n to the power of n. And me and Michael ended up going through it because I wasn't sure if it was in section 11.4, so I was trying to think of comparison.
Yes.
Which, I mean, we ended up dropping the 22,
Good.
but
Leaving
there
22
wasn't
out.
like, without using the ratio test, there wasn't a way to really like,
Oh, yeah.
kind of solve it, but
Okay.
not really.
So once we get to section 11.6,
But-
you guys will love it and hate it because some of these problems will become a lot easier, but then, anyways, we'll see.
I solved it, but I wanted to see how, I don't know if it would be like acceptable or like how you would go about it.
Well, okay, so the first step is to get a feel for if it seems this is converging or diverging. Because if you're going to use a comparison test, you gotta kind of, either if you're using limit, you want to know to compare it to a series that is converging or diverging, or if you're doing direct comparison, you have to know whether you go ceiling or floor. Is that everybody with me? So the first step with these comparison tests is you get a feel for what it looks like it's doing. That's going to set the whole thing, right? So how in the world would I get a feeling for what this is doing? You can try to plug in some numbers. You got to be careful with that. I'm going to show you an example if I can remember. Anyway, I did put it together and then I didn't bring it with me. So let's look at a few elements of this. It's 1 to infinity, is that right? So let's not look at the 22. Let's just look at this piece. What are some elements of this thing? When n is 1, what do you get?
1.
When n is 2, what do you get?
And that over
2 over
4.
4. When n is 3, we get 6 over 27. Right, so this is 1 plus a half plus 2/9, right? When n is 4, I get, multiply this by 4, right? So you just can multiply the previous thing with the next. So 24 over, multiply by 3, right? I'm sorry. 4, where are we at? 4? 4 to the 4th? What's 4 to the 4th? 64 times 4 is 256? No. Yes.
Yeah.
Is that cool? So 4 to the 4th, so 256, which isn't, which is what, 12 over 128, which is 6 over 64, which is 3 over 32, is that right? Who knows? 8, 240, yes, okay.
Mhm.
So what we're trying to see, so let's do one more, just because. 5 factorial would be 5 times this, which is 120, over 5 to the 5th, okay.
3,125.
We're getting serious now. 3,125?
Mm-hmm.
Which, oh crap, all right, Jeff, what can you do there, buddy? 4 over 625. Doesn't seem like it would go anywhere. Do you guys, quick side note. Do you guys know how to tell if a number is divisible by 3? You add the digits, and if the digits sum to a number that's divisible by 3, the whole thing is divisible by 3. So I was like, okay, 2 doesn't go into there, obviously, but 3 might. But 6 plus 2 plus 5 is 13, which is not a multiple of 3. So 3 doesn't go into 625. You guys said my with me?
Yeah.
You guys ever heard that? You know how to tell something 4 goes into something? The last 2 digits have to be divisible by 4, so this number. That's divisible by 4, because those are. Why does that work? Because 4 times 25 is 100. So 4 goes into 100 and something with 4. So 4 goes into 200 and something, 1000 and something, 1,000, I know, right? It goes into any multiple of 100 plus something of 4. So I just have to look at the last 2 digits. I'm sorry. I'm sorry. But again, these are little things that I like to, if I remember, when you get to a certain level of math, you should know these things. In fact, you're like, I should have known this shit before I could use a calculator. This is human freaking shit. Before you get a calculator, we had all these neat ways to do things, and they still are good and valid. Right? Okay. Sorry. And so, is that this? Yes. Bam, 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 bam. Okay. Okay, so this is not easy to tell what it's doing, but can we get a guess? So this is about 4 times as big as the top. This is about 10 times as big as the top. This is about, I don't know, what is that, Jeff? 30, 25 or something? I don't know. What is 625 divided by 24?
26.
26, okay, thank you. 1 plus a half plus, like, this is about 4 times as big as the top. It's a little more than that. This is about 10 times as big as the top. And this is about 26 times as big as the top. Right?
Mm-hmm.
So what would your guess be? I don't know if you guys follow. Do you see how it's approximately?
Yeah.
Okay.
It's getting smaller.
What do you guys think? I mean, n squared, 1 over n squared would converge, yes?
Mm-hmm.
So 1 over n squared would be 1 over 1, 1 over 4, 1 over 9, 1 over 16, right? And these are getting bigger, roughly equal, or at least even better. They're getting bigger faster, it looks like. And again, I'm really sorry. I just did a bunch of things that you might never think to do, which is not your fault. I've just done this more often, so I know what to look for. So this kind of problem is really not easy. So I'm just trying to give us some ideas of how to even feel this thing out. What does it seem like this thing is doing? The top is going to grow sort of like n, because it's like this. So if I make it Now, I want you to notice something. What is the bottom doing? So this is gonna go like this. What does n to the nth mean?
N times n times n times n.
Yeah. How many of these will there be?
N.
N of them, right?
So yeah, it's always gonna be bigger than the top, right?
Yeah.
That's where like, because you could take the limit then, and then you have to find a zero because the bottom.
Well, the limit being 0 is one thing, but it doesn't tell us, it just tells us it could converge.
Yeah, and that's where like, that's where I got a little.
So here,
upset.
this way I've written it is probably where I wanna stop, to be honest, because then you can use this form of this to try to set up a comparison. So if we feel like it probably is gonna converge, and again, you could use a computer or something to even go further out with the elements, right? If we feel like it's gonna converge, I wanna find a ceiling or a floor in that case. If I feel like this is gonna converge, I wanna find a ceiling, right, CC. So when I find something that this is less than or equal to. So if I replace some of these with n, wouldn't this be less than or equal to that? Isn't n bigger than n minus 1? By definition, right? Okay, I like it. Okay, so maybe, I don't want to replace them all with n. And I want this, let me see, this hasn't really come up, but if you go, I think it came up a little bit, if you go too far, you could end up with something that is the opposite of what you want it to do. So if I replace all of these with n, I get 1, and that obviously diverges. The sum of 1 diverges, right? If you just add 1 forever, it freaking diverges. So I went too far. So I only want to do a few of them. So like, I'll give you a little hint. What's before the 1?
N minus n?
No, come on, what's before the 1? 2. What's before the 2?
Oh, 3.
3. Okay, right? Okay, that's, if you convert, okay, that's all I'm gonna say. So it is a direct comparison, and this is the form to work with. Now I want you guys to try to do the rest. You wanna make this less than or equal to something, and like we said, if you replace some of these with n, that's doubly good. It makes the inequality right, and then you can cancel. You can already cancel that guy, right? And you can cancel some more shit. Okay, that's all I'm gonna say about that problem. Okay. Yes.
Can I just ask one more thing?
Sure. Yeah.
So when, like, you just have a bunch of negatives at the end, wouldn't you?
No. We're replacing n minus 1 with n. If I just replace that one thing with n, is this new expression bigger than that one?
Yes.
Definitely. Right? And then these two cancel. Now if I do that more, but I don't do it all the way, I'm not just giving the whole damn thing away, so I'm not gonna say anything else.
Thank you.
So factorials are neat, but they are not easy. In fact, I mean, for example, you can't integrate x factorial or something, right? We don't even know, again, we don't even know what 2.7 factorial would be. It doesn't really make sense right now. Okay. So factorials are relatively simple on the surface. You just keep multiplying until you get to 1. That's really easy. And 0 factorial now. We all know what 0 factorial is, and it makes sense. It's just not by definition, it's because that's what it has to be. Okay. All right, I love it. So that's definitely not an easy problem. That's one of the harder problems, for damn sure. And again, if you guys aren't doing much of the homework and you come in here and people ask questions, you're like, holy shit and a half. You know, but they're asking the really hard ones. There are some that are not that crazy hard here, hopefully. Anything else from like the practice test or the homework stuff? Yeah.
This is for the quiz.
Yeah.
Still at problem number 3. Right at the bottom one?
Number 3?
Yeah.
Okay.
The top one.
Oh yeah, so at the end of, after the quiz, I think I gave everybody hints on that one. How did the squares go? 1, 4, 9, 16, 25, right? How far apart are these, by the way? 3. How far apart are these? 5. How far apart are these? Interesting. Alright, so squares inherently are increasing by the next consecutive odd number. It's kind of freaking neat. Okay. Cubes are 1, 2 cubed, 3 cubed, 4 cubed. What is 4 cubed? 256. Wait, 4 squared, yeah. 216. 1, 2, 3, 4, 5 cubed. Wait, that's gonna be right. 125, so 4 cubed is 64. That's funny. You're doing 4 to the 4th power. Good job. Blah, 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 right? So if I saw a series that looked like this, a series or a sequence that looked like this, 3, 10, 29, 66, 127. Isn't that these plus? So this would be n cubed plus 2. So that one I counted for a little bit less. I just wanted to give you one that was a little bit, to really kind of think about how it was offset from something. Right? Again, a quiz, with sequences, there are so many things it could be that you just have to see more and more possibilities to know what's allowed, right? How much flexibility do you have in these things? So is that cool? And some of you guys had something based on just squares. Okay. Maybe. Okay.
We could do questions on quiz 3, right?
Questions on, yeah.
Could we, like, go over number 4? Or go, like,
Yeah, so let me do one.
like,
So everybody had this problem, but nobody had this problem. So I can say, might this series converge? So I saw way too many people saying oscillated, so blah, blah. No. Sine n oscillates. This does not. This does not oscillate forever. What happens at infinity right, so I can take this inside, because sine is continuous. What's the limit of the inside? What's the limit? Not-
0.
Yeah, 0. And what is sine of 0?
0. 1.
0. So might this converge?
Yeah.
Yes. Does it? We don't know. That's why I just asked, might it? You guys with me? What if I do this one little thing? What if I do this? Pi over 2.
Oh,
pi over
yeah.
2.
Right.
Yeah.
This is 1, so it wouldn't, or it would never.
Pi 2, which is 1. So might that converge? No, because the limit's not 0. Test for divergence, right? So some of you guys had cosine, some of you guys had natural log. So be careful, if the limit of the inside is 1, but it's the natural log of that, what is the natural log of 1?
0.
Oh, shit. Okay. Right, so you just have to look at the complete thing that's inside the series and say, what's the limit of that? The limit's gotta be 0 for it to have a chance to converge. So if I say might this converge, you just think, okay, take the limit. If it's not 0, then it doesn't have a chance. Yeah.
I was wondering after this, could you do number 6 from the quiz?
Yeah, A, B, and C?
No, just, honestly, my question is how to just show, like, derivative wise that,
Oh, so if you're trying to show, decreasing,
right,
right? So I think we did this problem earlier, didn't we? Like for part B, we did that one.
Yeah.
We did the derivatives, right? So we did the quotient rule and, right? For 6B, yeah. So maybe you're talking about, I don't know.
I think you were doing the corrections when you did it. Did they ask some answer again?
oh, okay.
Yeah, I think he was busy with the corrections.
Oh, okay, okay.
Yeah,
So, yeah, if you do the derivative, you end up with this. The bottom is always positive, the top is always negative, so this is always less than 0, so it's definitely decreasing. Because this is F prime, right?
okay.
And the funny thing is, and again, this is not a knock against you guys, but the most fundamental thing you learn in calculus is that derivative is slope. So any question about increasing, decreasing inherently means derivative, right? So if the derivative is negative in a certain area, then that means it's decreasing. And this is derivative definitely for every x at least 1, but it's actually less than 0 for every x. So this is always decreasing. The original function is always decreasing, so.
Is that from the test?
That's from the alternating series test. All right, so for 6B.
No, I was talking about the quiz.
No. Oh, am I looking at the test? Oh, shit. Sorry, man. So 6.
Yeah, I caught that.
Okay. Sorry, boo.
No worries.
Or some words. 6. Oh, yeah, this one, I tried to be nice, and it ended up being maybe evil, I don't know. Because I first made this problem, and I didn't say there was an issue with this. And then I thought, no, that's a little mean. Because in order to do integral tests, you gotta show that it meets the requirements. So if you do this problem, you actually end up not doing the integral because it doesn't meet all 3 requirements.
Right.
So, this is where we're talking about decreasing. Same idea. Exactly the same idea. So everybody, let's try to do this. Take this guy's derivative. So I'm gonna write it in the better format. Right, root notation is stupid. I wish we had never invented it, but oh well. Humans do stupid things. So everybody take a minute and take that guy's derivative. Now this is where we really have some algebra problems. So a lot of guys got the derivative to a certain point and they're like, I don't know what this shit to do with this, Jeff. Which, you don't do enough of it though, so I can't come down on you. We don't take you through this kind of thing enough. Right, so let's look at this thing. So do this to the point where you can. So of course this is a quotient rule that's got some chain rule mixed in, right? So I'll start catching up to you guys. So derivative the top times the bottom. So my song for this is top first, okay, and then minus the top times the derivative of the bottom. What's the derivative of the bottom?
1/2 x squared plus 1. Negative half and negative 1/2 times squared.
All over this thing squared. So what's the square of this thing?
1.
The whole one, right? Okay. This is where people do silly things, like cross through that or something. There's so much wrong with that. They're not the same, and this guy escapes getting divided? No, nobody escapes. Nobody expects this man to say research. So, what the shit? What the shit, Jeff? Alright, so watch this. The main thing you want to try to do with this most often is to factor the top. Because you're hoping the factors will show you one factor will always be negative and then you're golden. Does that make sense? So I want to try to factor this. Okay, so tell me, how would you factor this? No tricks, just how would you factor it? No tricks.
X cubed.
Take an x cubed now. Why do you take an x cubed now?
Smaller.
Smallest power. Don't you always take out the smallest power, because that's the
Yeah.
one that they both have? So I'm gonna factor this thing. How many x squared plus 1s am I gonna take out? To the what power? What's the smaller power? Didn't you just tell me we factor out the smaller power?
One half.
To the negative 1/2. So what else can I take out? I can take a 3 out, right? And an x squared plus 1/2, I'm sorry, plus 1 to the negative 1/2 power, okay. I really want you to see, that's just an extension of the shit you know for damn sure. You don't even think about this shit. So if you do it and you stop and you go, why did I take 3? Because it's the smaller power. Okay, smaller power is this one. Take that shit out. So what do I get when I divide this by negative 1/2 power? Don't I get
Just that's the.
a full one of these?
Yeah.
So I lose the 3 and I get a full one of those. Minus x, and then I took this shit out, right? So then all I'm left with is another x. All over x squared plus 1. I'm doing too much. Oh well, too bad, Jeff. It's pretty easy to make me do your work for you. Well, so of course what happens here? These
One.
cancel. So this is positive, this is positive, and this is positive, and this is positive. The whole damn thing is positive. So would integral test work? What does the integral test require? It requires that at some point it's always decreasing.
So not-
This is always increasing. Integral test won't work. Done. Okay. So a lot of you guys, yeah, a few people got the derivative correct, but then weren't really sure what to do with it, which, again, this is the kind of algebra you didn't get to play with much, which is unfortunate, but it's just an extension of this basic idea. Just take out the smallest power. You always do that. And with fractional powers, what's so cool is you normally take out a negative part and then something becomes a whole thing, which kicks a lot of ass, because then it can have like terms that you can do stuff with, right? Like what just happened there. Okay. All right. Anything else, guys?
Did you already go over number 3?
On the quiz?
Yeah, on the quiz.
Oh, yes.
Yeah.
Oh,
That was the one where we looked at the squares, for example, and then we said, so if I saw, this is n squared.
Yeah.
So if I saw this, 4, 7, 12, 19, 28, do you see how that's n squared plus 3?
Okay.
Yeah.
Oh,
Yes.
6C for the practice test.
Yeah.
It's cosine 2n or.
Yeah.
All of that. It's not alternating series, right? So
No.
you switch
It's,
to-
no, let me ask you real quick, I'm sorry. Cosine 2n, is that always positive? Is it always negative?
No, it's-
Is it positive, negative, positive, negative, positive, negative? Is it?
no.
No. So it's not truly alternating, even though it does have some negative, some positive. It's not alternating. You guys with me? Alternating strictly needs to be truly negative, positive, negative, positive. You guys remember squeeze theorem?
Yeah.
You remember what it was fundamentally, how you could build it? You had to start with the part of the function that itself was bounded, right? And on this problem, don't I say comparison? So part C is not alternating series, so it must be some kind of comparison test.
Right.
And we know that cosine is bounded, right? So, what do you guys think? This series, is the cosine squared? No. It's cosine 2n?
Yeah.
Thank you. Can you guys see, alright, that bottom's a little freaky, yes? Can you clean the bottom up and get a guess as to whether this converges or diverges? I mean, what's the bottom look like if you write this better? Does anyone know if this converges or diverges? Anybody have a feeling?
Conversions.
Why do you think that?
Because
You could do it. If it was just this, that would be divergent. That makes this power more than one.
Oh,
P
yeah.
series.
Be serious, right? That's one of those you desperately want to look for. So whenever you have like n's to powers, get them all frickin' together so you can see what the shit p is, right? So this would be n plus 1 times n to the 11th, 1 to 11th, sorry. So what would that be? Distribute that,
And 11.
n to the
12,
12 11ths,
plus.
plus other shit that we don't care. Right? It does not bother me that p is less than 1 because that's the dominant dude down there. It's just making the bottom actually a little bigger. It actually helps. If that wasn't there, that would suck. Actually, that would be nice because that would be different. Who cares, right? Okay. Something. I think we want to stay in here for a while. Not sure. Okay. So we feel like this converges, so we want to find a ceiling. You don't have to spell it, right? Just gotta find it. Thankfully. So I want to find something that is bigger than this. And real quick, I have people sometimes have trouble. Do you hear what I just said? I want to find something that's bigger. Is everybody cool with the way I drew the inequality? Let's get somebody that's hung up on I just said bigger, and they're like, that's less than. Well, I want this to be bigger than that. Okay. So what's the biggest cosine can be? 1. And how do I know? This is different from that one series with the cosine of lots of shit inside, because the lots of shit inside made it more complicated. This is just 2n. So as n grows, cosine is going to go between 1 and negative 1. So the highest, the absolute most cosine could be is 1. So whatever the hell that is less than or equal to 1 over this business. Now what do I still need to get rid of to make it truly p-series? What's a little extra dude?
Plus,
The little tiny 1/11th power on n, right? If I take it away, does it make the new thing bigger?
Yes.
Yes, right? So that's what you always try. If taking it away makes it work, yay, take it away. If taking it away doesn't make it work, you make this like terms. So then you can make it one term. Remember that? Those are the two things with this direct comparison that you could do. By the way, I love limit comparison would be exceptionally weird here because of the cosine. So this is a beautiful example. Does everybody agree? Are you at the point where you agree that limit comparison generally is better than direct comparison? Direct comparison is weird because you got the inequality, you got to make sure it goes the right way, is the floor or ceiling. Limit comparison is just make a different sequence and do shit, different series and just see what the limit is. Yes, it's a lot more direct, but it doesn't always work. It wouldn't work. Okay. So taking that away makes it work. This thing is a
P-series.
convergent p-series, therefore this is convergent because something bigger than it converges. So of course it must converge. Right? And that's my famous, slap him on the damn hand. Is your teacher right? I don't know. I don't know either, to be honest. Sometimes I feel like I might be alright. Okay. Maybe, yes?
For number 3, when it says, if we also know that it's bounded below, what can you do
Oh, is that on the quiz?
on the practice test?
Practice. Oh yeah, so there's a theorem. So if it's bounded below and it's, and we show that it's not increasing. So it's decreasing and it's bounded below. Decreasing and bounded below. Is there any chance it could diverge?
No.
The only chance it could diverge is if it wasn't bounded below. Because then it can go to negative infinity, right? But the minute it's bounded below, that's like a floor. It's gotta be convergent then.
Yeah.
Okay. So if it's always decreasing and it's bounded below, it's gonna converge to this bound. Well, it depends on if it's exactly, well, you get the idea. It's definitely convergent if it's got a bound below it. It can't go to negative infinity. Okay. And it can't oscillate, because oscillation would mean it's not always decreasing, right? And we just showed it's non-increasing, so it must be at least all decreasing, if not the same. Okay. I like it. So that theorem is not something to memorize. It's just see why it makes sense. It's just like a floor. It's got to make it convergent then. Well, I say, see, okay, we go. In this case, the floor is not going to infinity, right? So it's just sitting there. So it's not letting it go to negative infinity this time. Okay. Okay. I think I got tired by the time I got to number 7. Let's do this together. Number 7, what do I have to show before I can use the integral test?
Positive.
It's going to be positive, continuous, decrease. Positive, continuous, decrease. Okay, so continuous is very often the easiest part. I think most of you guys have picked up on the fact that if it's a ratio, if it's a rational thing, it's easy, it's quick. It's just continuous on its domain. Can anyone tell me the domain of this thing? What was it? N to the 4th. Used to be a plus. Yes. Did I say 2? I think I said 2. Makes sense, because otherwise it'd be 0 on the bottom. That'd be freaky. What did I just say? What did I just ask you? Man, I'm tired. Sorry. I literally just figured out what I just asked you. That's a good sign, Jeff. It's time to retire.
Okay.
Now I need some more Graham up here before doing that. So, does anyone have the answer to the question I just asked? What did I ask you guys?
Is it continuous?
Is it continuous? Thank you. So the top is continuous. Bottom is continuous on its domain. So this thing has to be continuous. It's continuous on its domain. So there will only be a problem if there's a place where it's discontinuous to infinity. So that would only be where the bottom is 0. Now, in checking this, you actually do what you need to do to be able to integrate it. Did anyone try to integrate this thing? And why not? Oh, you did? All right, don't say anything. Just, yeah. Did you use U sub?
Yeah.
Okay, good. And some of you guys are like, how the shit? Okay. Can you factor the bottom for me?
Yes.
How does the bottom factor?
I squared. I squared minus 1. All squared.
Yep. Right? And where is this discontinue? Where is this?
Negative 1 and 1.
Yes. Which, now you see why I started at 2. Well, I started 2 for a few reasons, but that's definitely one. You guys semi with me? So, in fact, for everything above 1, this thing is definitely positive. So positive, top and bottom check. Continuous, top and bottom. The rational function is continuous on its domain, and this domain is good. Includes everything here. Check. So only got a problem at 1 and negative 1. And we hardly ever worry about negative 1. So now I just got to show it's decreasing. And what's our... Well, again, what's the other way besides derivative? Just to kind of show you, this does sometimes work, but it's not always a great way to do it. But what's the other way to do it besides derivative?
Show the next term is less.
Yes, so show that an plus 1 is less than an. The next term is less than the previous. That would be decreasing, correct? So let's see, what would that involve? I'd have to show that is less than this. Do you guys understand that's not an easy thing? One thing that makes this easier is we already showed, again, you could just do the derivative, correct? And at this point, you start to really appreciate the quotient rule. You don't hate it as much, right? Because you see the alternate thing, and you're like, okay, I can deal with quotient rule. Everything's positive here, correct? Didn't we show that?
Yeah.
So can't I just multiply and it won't do anything to the inequality? What's the only time the inequality will switch?
Negative sign.
If I multiply by negative, right? And do you guys know why that's true? Why do we switch the sign when we multiply or divide by negative? Do you know? Real quick. Which one is bigger?
2,
2. Let me divide by negative 1. What do I get?
2, 1,
Which one's bigger?
1.
What does the sign do?
Oh.
Okay. So this is perfect. I love this. Why does the sign flip? Because it does. It just does. Of course it does. Because when I multiply by negative or divide, it's called a non-order preserving function because I change the side of 0 it's on. So whatever was bigger is now smaller. Whatever was smaller is now bigger. Right? So anyway, because that's why. So whenever I show people that and they do it, I never want somebody to do something just because a teacher told them to. I'm like, you gotta freaking really know why this shit you're doing. Okay, sorry. I'm doing a lot of tangential stuff. I'm sorry. So you could multiply this up and you could multiply this down. Do you really want to do it? Does that look like it's an exciting thing? You could bring this up, you could bring this over, do some shit with it. A lot of shit would cancel, but do you really want to do that? You could. I really want you to see. You can multiply this out, you can multiply this up, multiply it out, multiply this up, multiply it out, and then cancel, and then see if whatever's left is obviously less. You can totally do that. Or you do it. Yeah. And derivatives are relatively simple. So anyway, we've done enough of those derivatives today. You guys agree? If you want to see a derivative, I'll do it. But okay. So the main thing with this then is doing this integral. And now that you had to factor it just to answer this question, now the integral becomes a little bit easier. Now, can everybody see that this is a total U sub?
Yeah.
Yeah, on their T. Okay, I like it. So total U sub blah blah blah. That's on the answer key. I just didn't put these things on the answer key because I think Patch Jeff was tired. President Jeff is tired. So let me do this. Let me give you the answer key. So you got some time to kind of check my answers. I'm averaging about a 97 on my answer key. That's pretty good. Oh, one more. Thank you. Anytime. Thank you. Somebody here? Who's here?
Oh, nice.
Yeah.
What?
I think it was a 3.
Oh, yeah, no, it was
Oh, I'm sorry, man. Don't take it personal. All right. So number 2 is sort of like that question, but I made it a sequence instead of a series. So if it was a series, it would obviously diverge the number 2 problem. 4B is a really good example. So geometric, the only way to make geometric more difficult is to throw like multiple geometric in one. So you have to kind of tear them apart, right? And then maybe to have the powers not quite match up, so you have to pull a couple things off. So you see how it's 1 minus 48 plus 2 over 5? So there's 2 separate geometric series that you have to break apart. And then the power on the 4 and the 5 are not the same, so you have to pull a couple 4s off. So that's the kind of manipulation you have to do to get it to be in R to the n kind of form. Okay, maybe. TFD is test for divergence. Yeah, what is it? Where did it go? Which one was that? Yeah, number 5 is sort of like a simpler version of number 6C. So on this stuff here, I'm getting too many people do this kind of thing. If you're at the point where you got this, let's say you got this, right? And I'm getting way too many people tell me this, and then they put 1/3. Does anyone not have a problem with that? The way I'm asking, you should have a problem with it. You should have a big old damn problem with it. This is telling me you found infinity, you put it there, that's some cool shit, I want you to. I used to say I want to see it, but now I'm not sure I want to see that. So if you find infinity, I want to see it. I've got to see it. It might suck my soul out or something weird, it might be like the end of Indiana Jones. Close it! You know, it's terrible. No, okay, you never saw Indiana Jones? The good one, the first one, when they were good. No, so you can't plug infinity in. So what are you supposed to do with this? You just do this. There, okay. That's shorthand for, as the inputs get bigger, this entire thing gets smaller. That's the shorthand. We can't plug infinity in. We can just talk about what it does as the inputs get bigger. So we have to get away from seeing infinity as something we actually plug in. And I think when you do L'Hopital's, so if I had this, I don't know. Oh, screw it. I don't know. Sure. That's not what you want. T goes to infinity. Sure. Okay. It's not going to do what I want to do. It doesn't. So isn't this infinity over infinity? Right? So the form is that. So then I think that's completely fine because that's the form it is in. That is not an answer, that's not work, that's none of that. That's the form it's in. To actually put infinity in there doesn't make sense. Okay, I'll let that go. Okay. So I think that might get in your head and make you think that you can plug infinity in, but you can't. So did I tell you guys I used to tell somebody who really couldn't stop doing that? I said put BFN for a big freaking number. Right? Big freaking number. So you can at least have a visual and think big freaking number. Okay, that'll go to this. Right. Yes. Sorry?
And I get a stapler.
Oh, stapler. Yeah, it's up here. Yeah. Anything else from the quiz or from the practice test or just generally? Did everybody get it? Yes.
If the direction, derivative,
Take the derivative.
if you take the limit of determining convergent and divergent, the limit doesn't equal 0, it's divergent.
Yes.
No matter what happens.
No matter what. So if I give you a series and I say is this convergent or divergent, the very first thing you do,
The limit won't have.
yeah, then it's divergent. Yeah.
The divergence.
No worries. And why does that make sense? If the limit is not 0, why do we know immediately it diverges? You give me the smallest number you can imagine, but you add it an infinite number of times. That's infinity, right? So if the limit is not 0, if the limit was 1 times 10 to the negative 18 trillion to the trillionth power, that's stupid small. But if I add that forever, that's infinity. Yeah. So that's why the limit has to be 0 to maybe converge. And then it's a question of, is it decreasing fast enough? Like 1 over n does not decrease fast enough. I think that still trips us out, and I don't blame you. If I look at this, it does not look like it's gonna add to infinity, right? It doesn't. And I don't blame you, it doesn't. But it will. It's crazy. So the book kind of shows it a different way. I kind of showed it once we did interval test and all that kind of stuff. The book has a nifty way. It looks at the partial sums. So if you need an expression for the partial sums, you can do the limit as n goes infinity of that. And see what that is, right? Okay, so let me ask you this. Based on what I just said, if I give you this, and you show the limit of this is 0, what does that mean?
It has a chance to converge.
Has a chance to converge,
Yeah.
right? Okay. If I tell you that given some sum, the SNs are this. We've seen problems like this. And the limit, what's the limit as n goes to infinity? Of course, of this is still 0, right? So does the series converge? Hell yeah! Sn is the sum up to the nth piece. So this means sum up and up to the infinite. Sum it up forever. So this sums to 0. So if there was a series, really what's make sense, whose partial sums look like this, does this mean that this is what is in here? Hell no. I really want this to make sense. This is what the partial sums look like, right? Given a series, if I get an expression for the partial sums, which is not easy most of the time. If I can find an expression for the partial sums, I can just take the limit and that'll tell me what the summation is. We've seen problems like this. They gave you an Sn, and you just had to take the limit because that is what the sum is. If I just let n go to infinity, that's everything. If I just have the series, this being 0 or being something, being 0 doesn't tell me anything, it just tells me it might converge. If it's not 0, then it doesn't even have a chance. Okay, so if Sn was 5n minus 2 over 5n plus 3, what's that limit?
1.
What does that mean?
It doesn't converge.
Here's the. What does that mean for this series? Converges to 1. Done. But if the limit, if I have something else, and the limit of Bn is 1, what does that mean? Diverges. Because if the elements go to 1, you'll be adding 1 forever. This is, if I add it up to the nth place, and I get this, no matter what n is, what's the complete sum? Well, let n go to infinity. That's the complete sum. I'm done. So as long as this is not infinite or oscillatory, then this is what it converges to, right? Okay, that's a little thing, but it shows up, sometimes we get those SNs, and I want to make sure you understand why you're allowed to just take the limit here and be done, but if you take the limit here, you got more work to do, right? Okay, maybe. Yes?
So when you take the limit of the whole, like the sum of all the numbers, and you get 0, it's because it's super close, but it's not 0.
Well, this would probably, if I have a series whose sums look like this, it would have to be some kind of alternating series. And that's why it would be 0. So this would be really difficult to figure out what series would have partial sums that look like this. That would be a really crazy hard problem, right? Okay. So let me see real quick. I just want to give you something concrete, and then I'll see if there's any other questions, and then we'll head out if everybody's kind of like brain is hurting. So if I had this, I don't know, what's a good one to do? Let's just do, sure, okay. So this is 1 plus 1/4 plus 1/9 plus dot, right? So this is, so S1 is 1, S2 is 5/4, is that cool? S3 would be 45, 49, 36, maybe? Yeah. 49 over 36. Maybe? Okay, I don't know. And then, so can you, I just wanna show you this quick example, get out of there. Plus 116, I don't freaking know. Something, okay, whatever. So you would have to determine, remember, like I give you those problems where I say figure out the nth term, like the one that was based on squares and cubes? You'd have to sit down and figure out, how do you write an expression that captures, when n is 1, you get 1, when n is 2, you get 5/4. That would be the expression Sn. Then you can take the limit to actually figure out what this sums up to be. Does anyone remember what this sums up to be? It's in the homework. Pi squared over 6.
Yeah.
So do you think that this is going to be a nice Sn to have? No. In the homework you learned that this is equal to pi squared over 6. Right?
Yeah.
I don't blame you if that's not like obvious. That's not like, of course it's pi squared over 6. No, it's not obvious. I did post the proof of that to the website. And the cool thing is, I will pull it up when we get further in chapter 11, when we learn enough to actually know every step of that proof. At the moment, there's a big step that doesn't make any damn sense, right? I just want to throw it up there just in case anybody want to look at it. Okay. Anything else? Okay. I appreciate those of you who are coming in for help. I completely understand, because I think I've told you when I was in college, I was going to college plus 3 jobs. So I barely had time to go see my instructors. I definitely didn't have the time for tutoring or anything. So I appreciate the fact that your schedules don't often leave room for tutoring. I want to remind you, because somebody was in here and they were surprised I was here. I am here at 5 o'clock every day. I try to be as close to 5 as I can. So you can come early with any damn questions you got, right? And I'm in the Mass Study Center a lot, and you got tutors and blah, blah, blah. Okay. So there's a lot of help. You're not by yourself. I know I can't make sense all the time. I wish I could, right? And has anybody found, like, I post my YouTube stuff, but if I'm not making sense in the first place, I don't care how fast or slow you play me, I'm not gonna make sense. Has anyone got on YouTube and found decent videos from somewhere else? Yeah. Like MIT posted a bunch of their lectures up for everybody. And believe it or not, they're accessible. They're not like crazy highfalutin stuff. You can actually understand what they're saying. There's just a ton of freaking videos out there. And there are people that make a lot better videos than me, because my point is not to make a freaking video. My point is just to lecture and then capture what I can. So, if you want to, if you found something that's really good, and I keep meaning to do this, I would love to make a list of things and put up on Canvas for people to access if they're not aware of these other videos. Because what got me through my courses a lot of time was getting other textbooks that the professor didn't pick. Because there were always a textbook that this section, oh my God, the way this guy wrote this makes sense. Oh my God, the way this woman wrote this makes total sense. So I have to piece together to make a complete understanding of the course. So, but nowadays, thank God, you don't have to try to find textbooks or pay for textbooks like crazy. You can just go to YouTube and get past all the shit. There's a lot of shit. And then you find some really cool stuff, and you go to their channel and just see what else they got. Okay, so if you think about it, I might send an email out asking you, but send me some channels that you found that are good. Okay? All right. And if no other questions, you guys are free to roam around the earth. And I will see you at least Wednesday, if not before.
Number 6 on the